Okay, we're going to start by watching a quick video and doing a warm-up from today and yesterday. And I think you guys will figure out the theme pretty quick. Hopefully this isn't too choppy for you. Oh, easy. So I think you guys are getting the idea. This is a gigantic gun. It's called the T-Rex gun, the elephant gun. And the question I have to start is, what feels more force? The bullet, because it accelerates more? Person in the gun, because it has way more mass? Both feel the same force? Both feel no force, only change in momentum. So what do you think the answer is? Here comes the answer. The answer is they both feel the same force. And this is a review of Newton's third law. For every action force, there is an equal and opposite reaction force. And what happens is the bullet is so tiny that it accelerates really fast. But given the same force, the gun plus the person have so much more mass that they only accelerate a little bit. But they both feel the same force, action, reaction. So what I want you to do, starting on page 13, is, if you haven't done this, is to solve for the acceleration of each using this formula. Okay, you know force is the same. Find the acceleration of the bullet and the gun, and then finish this sentence. For example, force is 1802. The mass of the bullet 0.1. Solve for acceleration. Divide this over and solve it. What are your answers? So pause the video at any time, because I'm going to be moving fast today, but I can online, because you guys can pause and listen to it again and again. Acceleration bullet equals meters per second squared, very fast. Acceleration of the, we'll call it person, equals something around 16.2. So the question is, even though force is the same, the bullet accelerates more because, and then finish, the person accelerates less because. So finish those, because these notes are critical for today's lesson on 13. Skip these. Okay. Now we're going to watch two charges. We have a more massive proton and a less massive electron. This is a visual diagram of the process we're going to go to. And now this is positive and this is negative. They feel an attracting force towards each other, and that force is equal to some constant times the charge of the proton times the charge of the electron divided by their distance squared. So when we know this attracting force, and if we know their mass, we can then find the acceleration of each. And this is your objective on the advanced topic. You need to find the acceleration of a proton, the acceleration of an electron, by first finding this force. And it's going to be a little bit of work, because we're combining ideas, Newton's third law, Newton's second law, and the attraction between electric charge. But we can do it. And the first thing is, I'm just going to put this right here. So we need to solve for acceleration. Step 1, this is all going to be done on page 13. And the first thing is list what you know. And step 2 is the setup, starting with this formula. So here's our list. Okay. We know that the charge of a proton and an electron are both the same. They're the same charge. The only difference is the direction of the electric field. So for example, proton equals charge 1, 1.6 times 10 to the negative 19. Electron equals charge 2, 1.6 times 10 to the negative 19. Distance, the average distance inside the nucleus is 1.5 times 10 to negative 10 meters. and the average and the K, this constant, Coulomb's constant, is 9 times 10 to the 9. So now we take all of this over and plug it in, and I'm going to do it in fancy colors because I want to make a special point. There's our setup. We've got K, we've got our two charges, and these should be times each other. We've got, oh, and look, I made the classic mistake. See how this is squared? So I need to take this number and square it. That wasn't even on purpose. It's just that easy to forget. It happens all the time. So we've got the setup, we've got our lift. Let's go to step 3. Step 3. Solve for the bases. Okay, so we've got this. And the bases are all the first numbers, not the exponents. I've conveniently done them in black. If we pull these all out and set them up the same, it's actually not that hard of math compared to how this whole thing looks. And I'll keep doing it in red just to remind us. Okay? Now I can do this. Now I just need to do this in individual steps, and it'll help with making errors. When I say individual steps, I mean this becomes 9 times 6. 1.6 times 1.6 is 2.56. Divided by 1.5 squared is 2.25. This becomes 9 times, divide these two, 1.137. And now this equals 10.24. So I just solved for all the bases. The next thing is going to be step 4. Solve for exponents. And I'll do it in blue because I did the exponent numbers in blue. And we take them all out the same way and set them up the same. We've got 10 to the 9 times 10 to the negative 19 and don't forget the square root. I'll do it in red again. Okay, first thing, let's do these guys on top. When you multiply exponents, you're going to keep the 10 and add these two. So for example, this becomes 10 negative 19 minus 19. So now we have 10 to the negative 38 divided by 10 to the negative 10 squared. Next rule, when you're squaring exponents, you multiply. So this becomes 10 to the negative 38. Negative 10 times 2 is 10 to the negative 20. So this is still out front, we're just leaving it for now. Now we've got to combine these two. So we're still in these brackets. Now let's combine these two. When you're dividing by exponents, you need to invert this symbol. So when I say invert, let's make this a positive 20 now. And we're going to move it up here. So this becomes 10 to the negative 38 plus 20. 10 to the negative 18. This was all the stuff inside the brackets. And now I can bring this over. 10 to the 9 times 10 to the 18. Same thing as we started here. When you're multiplying exponents, you just combine them. This becomes 10 to the 9 minus 18. And our final answer is 10 to the negative 9. Because we've got 9 minus 18. And so our overall, we've got our number from before. Here's our answer. 10.24 times 10 to the negative 9 newtons, because we were solving for a force. Okay, that's the first part. We just solved for force. So I'm going to grab this right here and take this to the next page. And I will paste that out. So this is the first part. Now this is the second part of this. We need to find acceleration of a proton and acceleration of an electron. Let's start with a proton. We're going to use this formula. The proton's mass is 1.67 times 10 to the negative 27. The electron's mass is 9.11 times 10 to the negative 31. And we've got our force, we've got mass, let's find acceleration. 10.24 times 10 to the negative 9 equals 1.67 times 10 to the negative 27. All times acceleration. So here's your mass, acceleration, and force. Here, let's just make that clear. So when we, just like before, we're going to divide, and I'm just going to say we're going to divide by all this stuff. And I'm going to set it up over here just like I did before. We have, oops. Okay, come on back. Going crazy now. Let's stop this. You're going to divide here, 1.67. Going to divide here, 10 to the negative 27. And then you'll have your answer, because you divided by stuff. This is around 9 point something times 10 to the negative 9 plus, because we changed this one, 27. So this equals 9-ish, around 9, times 10 to the 18. And if you do the same thing with the electron, your electron answer should be, you divide by this number now, 1, around 1 times 10 to the 22. And those are your two answers. That's the acceleration, meters per second squared. Okay, you have a practice problem on page 552, number 9, and the answer is 16 times 10 to the 3. And all you're doing is solving for force, just as a practice for the big setup before. Good luck.